Welcome back and welcome to the Everything in Suite. So the Leetcode problem is the number of the smooth descent period of stock. So we're given an integer array price representing the daily price history of stock, where the price of index is the stock price on the index day. A smooth descent proves a descent period of a stock consists of one or more continuous days such that the price on each day is lower than the price on the preceding day by exactly one. So the first day of the period is exempt from this rule. Alright, we just need to return the number of the smooth descent period. So if we go to try to do the diagram for this XML. Alright, maybe I could make it a little bit small. And voila. Make it small again. Then zoom it out. Okay. So we have a definition called the smooth descent period of a stock consists of one or more continuous day. That means like one or more continuous day mean like even the one day can consider the smooth descent period. So that is the reason why we are including the 3 alone array in here, 2, which is on the value in the single array, 1, 4. These end up, and then on each day is lower than the price on preceding day by exactly 1. So preceding day by exactly 1 mean like for the price, that index of the second day should be exactly value 1 lower than the previous day. That is a descent period, smooth descent period. So to calculate that, we have option like 3, 2, which is the 3 minus 2 is a 1. So that's why we are in here. And then 2, 1. So if we calculate that, 2 minus 1 is exactly 1 here. And then 3, 2, 1. So 3 minus 2, 2 minus 1 is all exactly 1. So all these ends up and combination make the 7 counts. 1, 2, 3, 4, 5, 6, 7. And then the output is 7 here. So if we move to the next second XML, we are given like 4 integers in the price array. And then they provide like 8677, which doesn't make any like preceding day by exactly 1. So that means like we can only count the price of originally, which is a 48677. So there's 4 descent period like 8677. So the same for the number 3, since there's only 1, so we just return upwards of 1. I think that is something like dynamic programming, but I think we can just use a simple iterative approach by using the counter of the length. Let's call like, alright, since the price minimum length is 1, we can count like the result of the answer is 1 initially, and then we need to calculate the length also 1 because we have at least one price length in the price array. And then what we're gonna do is I'm gonna do the iteration from 1 to the, let's call like count price dot count and then count. So I'm gonna do like the valuation like if our price of index is equal to the price of index minus 1 minus 1. So that exactly we are measuring like comparing the 2 index. Let's consider we receive the 2 index in here. So I'm in the index 1, which is here, and then my index minus 1 is exactly here. Yeah. And then, yeah, instead of doing the calculation, I just check the minus 1. Normally what I would do is, just minus 1 and we check the index value is exactly the same or not. If it is exactly the same, what are we going to do? We're gonna increment the length by 1, and then if not, what we need to do, we need to reset the length to 1. If everything went well, we just increment the reset with the length, and then we just return the reset here. So if I have to dry run through this problem, so the origin of the count, let's go for the HTML1. We have a count of 4, and we're going from the 3 index, from 1, 2, 3. So initially we are comparing the price of index 1, which is the 2, is equal to the price of index minus 1, which is 3 minus 1. So it's exactly the same. 2 equal to is same. We're going to increment the lunch by 1, which became the lunch is 2. So we're going to end up like reset plus equal to lunch, which will make the reset to the 3. And then next step, we don't have a 1 anymore since we use a 1 in here. So next step is price of index is 2. So our index 2 is 1. And the next is index 2 minus 1, which is 1. The value is 2. 2 minus 1 is 1. And then we're going to increment the lunch by 1, become 3. So 3 plus 3 will make the result to the 6. Right? And then we only left for our only one less iteration. So index 3, which is the last item, and it's just 4. And then 4 minus 1 is index 3, which is 1. So 1 minus 1 is 0. So end up we moving the lunch to the reset to the 1. So 7 plus 1 is 6 plus 1 is equal to the 7. So that is how we got the 7s in here. Right. I think if I have to, let's try to run the program that parts, or do I have a typo in here? Exactly. I have a typo of extra dot in here. So if I try to run it, yep, I think that is pretty much. Let's try to submit it, solve all the test case or not. Alright, I think for the time complexity sake, that will be the O of n, since we iteration from the index 1 to the end of the array, and then the memory will be the O of 1, since we don't use any extra data structure here. Yep, that's pretty much for it, and see you in the next video. Bye.